parametric in interior designs. If you know about my practice, I am doing large-scale architectural projects, variety of things. Not exactly interior designer as such. Very few interior designs I did in my career. And most of the time interior projects are actually the byproduct of my architectural work. But because I'm doing coding since now last 30 years, and that is helping me into even parametric designs. So that converted into even parametric interior design. So today I'm giving you just the basics. Now everybody knows about parametric interior design, what is parametric architecture or digital architecture. And in 14 minutes I cannot teach you exactly how to do it. But I am going to tell you the basics and what you can do to actually learn or do this kind of practice. So the content for this presentation, we will be talking about the parametric as a base, the basic subject, parametric architecture or interior design. Then the design process, the different softwares we use, the form conceptualization, then various materials, then the use of CNC machines to achieve that design, the form rationalization, different environmental simulations. Then I'll be talking about few references, so it is more of pictorial, and then few case studies, my own projects. So if you know what exactly parametric, how many of you know what parametric design is? Can you please raise hand so I understand? Very few. I think, okay. And how many of you are designers? Okay, so most of you are actually into designing. So you must know, this is the next stage, this is the future. And parametric is, you do series of processes, two different variable parameters, and you achieve a form which is unimaginable. So the thing which you cannot imagine, you have to execute on site, and there is a process for it. So I cannot draw these kind of elements on normal software. I cannot use normal AutoCAD and get the form like this. Even if I get the form like this, I cannot rationalize it. So execute it on site is a big challenge. And to visualize and to rationalize it. There are different softwares, so we will be talking about the softwares too. And if you know particularly the element there. Yeah. So this is the circuit which generates this diagram. So this is unlike our normal drafting process. We don't draw line by line, but we make a circuit and that circuit generates the drawing. So if you see anything straight is artificial. So human has created straight line. Otherwise nature has got only curves. Okay. So we have two forms and what you find in them, there is a symmetry, certain kind of symmetry which are called asymmetrical symmetry. So in nature we find a lot of these kind of forms which are symmetrical, but they are not exactly symmetrical. They are varying in proportion, varying in size, but there is some kind of formula, there is some kind of evolution which happens and we get a very interesting form out of it. So let's say this. There is a symmetry, but not by dimension. The symmetry is by the proportion, the form. And then why we want to do parametric? Because these are different kind of aspects which you cannot achieve. Which we cannot achieve by our normal drafting processes. So that is why we use parametric. And then we can create this organic and very complex shapes. As I said, you can imagine them, but you can actually execute them by using parametric. We can rationalize. So when we rationalize, there are multiple parameters, there are multiple factors there are multiple factors and parameters on which you can actually do the analysis and you get a proper form out of it. So we'll see how the process is in the next few slides. And when I design a structure, am I sure that I'm designing it's stable? So most of the time what architects do or what designers do, they make a structure, they design the structure, they send it to the structural engineer. The structural engineer says this is not safe, this is not possible. Or maybe even for services it is not possible. So you can do online simulations or you can do real-time simulations and you check whatever you are designing whether it is structurally safe or not. So as I said, you can actually do optimization through various plugins. We'll see how to use them. And then finally, whatever is designed on computers cannot be executed manually. So you need machines to do it. So we'll see how to use machines for that. So the designing process, in my office we use variety of softwares. So right from surveillance to entire digital architecture, the portfolio is more than 200 softwares. But what we use is not more than 40 or 30 of them. So the complete system has changed in the last 5 years. So if you see the survey we used to do, now it's a point cloud survey. So I don't know how many of you have actually done point cloud survey. Very interesting. And then right from survey or drone survey, you collect the data, you do the modeling, not in normal software, but we use software which supports your modeling, very complex modeling, like Rhino. So in the Rhino you use Grasshopper for parametric, or you use various other plugins like Kangaroo, Karamba. There are a number of them. There are more than 500 plugins for Kangaroo itself, for Grasshopper itself. Then there are these environmental simulations, softwares like Ladybug, then you do building information modeling on Revit or other softwares like right now we are using RISCAP for building information modeling. And then finally visualization on one side and fabrication. So you use CATIA or you use CAS to execute those forms. So basic three softwares which we explored, one was EcoCement generative component by Bentley. Then one more software we know Dynamo and Revit. But I found them little amateur kind of. The one software which I know the most for parametric is of course Thane and Grasshopper. The combination is fantastic. And this is the circuit which I made for one of my installation. So circuit looks like this. Although it looks complicated, it's very easy. And the best part of it is parametric. When I say parametric, I want to check anything, just move the slider, I get different result. So we'll see how we get to that. So the first is finding the form. So conceptualization, the software helps you. Nowadays there are more complicated softwares, but more complicated for output, more easy for input. We will talk about them later. But then for the basic form conceptualization, the software helps you. I'll tell you exactly how. This is an example. I made one circuit. How that circuit helps me to get different iterations, different alternatives of one form. So different iterations of one form so that I can actually decide onto my form itself. So as I said, there are different parameters for finding the form. When it comes to architecture, I have got more parameters to think about. When it comes to interior, possibly the number of parameters or number of constraints will be much lesser. Now there are different softwares, there are different plugins. So this is one plugin for form finding. I use it a lot. It's called T-Spline. So T-Spline was a very interesting plugin made by Autodesk working in Rhino. Now both of these softwares are like rivals to each other, but still Autodesk had supplied this plugin for Rhino. One time they said now it's discontinued. And then everybody was like handicapped. And Rhino came up with similar software called Subdue. Exactly same. So I was using T-Spline before, now I'm using Subdue. So when I say I'm using, there are many international accounts they are using, I want you people to explore this. I cannot teach you everything in a small presentation like this, but I'm just giving you orientation to it. Now, before we decide onto the form, which material I'm going to use, the property of that material I need to consider. And according to that, I come to the final design. So each of those different materials, if I have to consider this kind of design, so plywood, cement boards or HPL, GRC, FRP, solid surfaces I can use, good plastic component of course, steel aluminum, the most favorite, 3D printed plastic and resin. So nowadays almost every form is possible with CNC machines. Most complex forms are possible. So we'll see how these machines to be used on these different materials. For architecture, there is one factor which is common, if you can see, steel. Because in parametric, right now there is only one method to achieve parametric form in concrete, that is 3D printing. But if you don't want to go by that route, then steel is a common material and you can use various other materials like tensile fabric or metal, stone, tiling, GRC, again same glass, and then EGF, that kilo-like material. Most of these European buildings now they are using. I saw that in Australia on one of the railway station. So there are different CNC machines. When I started working on this kind of forms, and I thought these machines are not available, you'll really surprised to know this. Alone, Goregaon has got more than 500 machines. The number of these factories, they are making the small mock-ups, gift articles, the stocking, everything. And they don't know what they can do with those machines. When we went to exhibit our form, and they saw the way we are using it, they were amazed. So we can actually use all the different kinds of CNC machines to achieve our forms. So the axis CNC machine, 5-axis CNC machines, they are all available. Laser cutting on stone or router on wood, and then the water jet on stone. So there are different kinds of CNC machines available. Water cutting, there are a number of these machines available in Delhi. Then this foam router is very common. What is new is this concrete 3D printing. IIID has done a lot of research into this. Now, any form, any design, they are ready to execute. So besides that, see, there are very innovative CNC machines like RoboFold arms. Kuka arms are there. So actually you can use them to paint your aluminum sheets for your design, and then you can flat that on the building or on any surface. Bricklaying machine. Now see that parametric shape which has just by laying the brick at different angles, got that form. Then of course there are different ways. When you visit that building, which is building in Sydney, very interesting building by Franco Gehry, and just by changing the angle of the brick, we have achieved that design. Then it's called this form rationalization. So this is more towards architecture. So when we design the building envelope, we actually do a lot of simulations, and we actually can check what is the heat gain, what the beam pressure can be checked. So there are different plugins for this software. And any form like that, if I want to design, I want to see whether that form is stable or not, there are different plugins again. So this is plugin for Convert Physics Engine. It works mostly for tensile fabrics and free-flowing forms, but then you can actually check the stability before finalizing the design. And with the software called Karamba, for any complex shape, you can check the stability before doing it to the structural engineer for designing. So it gives the deflection. How it works? Before actually finalizing the shape, the form, the structure is that the software is telling me how much displacement is happening, how much deflection is happening at individual mode, or how much tension or compression each member is actually taken care of. So I can rationalize the form better. And there are these different simulations, honeybird, ladybird, honeybee, and grasshopper, this dragonfly, spider, different environment simulations. So we are trying to explore. So last almost like 10 years I'm doing this, and I think I have explored only 20% of it. And then there is this exchange of data. So there are various other softwares. You can take input your data, you can give data from one model to this. And nowadays, these softwares are so powerful that Rhino and Grasshopper can deal with Revit, ArchiCAD simultaneously. These are few references. So what we can achieve through this. So here spaces, you can achieve this kind of design. So this is a reference of building in Singapore. You can create this kind of elements. Lobbies, lounges, sitting. There are different elements you can use in interior design. So flooring, ceiling, staircase, furniture, lights. So these are few elements are taken from actual sites or from internet. So Bombay Airport, Tipu Terminal is the best example of parametric. So this length of the cylinder is being created, and then you can get this fluid form. Or this rectangulars or square pieces at different angles from the top, and you create a very dynamic form of the fit. Different type of staircases like this. Furniture elements. And these are very basic. In fact, this is not even 5% of the parametric what it can do. Lights, you have absolute multiple options. You can use almost every material possible. You can do digital printing, any form design. So pattern called Vermeil in parametric language, and you can do almost wonders in that particular design form. So these are the options for lights. But understanding how to use these kind of forms, so there is something called a seed. Because parametric, once you write the definition, you can always use a seed and it will generate a different output. So the seed can be anything. The seed can be a number. It can be number of points. It can be a curve or surfaces or geometry. And to generate a design, there is something called an attractor. I'll try to explain it in few slides. So there are different types of attractors, like points, curves, surfaces. Then there are image seeds. You can take any image and feed that as a seed. To change the image, you will get different output. So writing a definition of algorithm, that is important. Once you wrote that, you can feed different seed and you get a different output. So this is just one example where there are two sets of points that are being used as seed. And when the definition is written, we want the software to think like this. So I suppose want the software to think like this, connecting top points with the lower points, creating those curves, then merging those curves, doing a Boolean operation, a union operation of all those 5 items to create a complex form. Now, this is the definition which is written. I change the set of these points, I get a different output. I use, instead of cylinder, I use a cube, I get a different output. So, once the definition is written, I can keep on changing the output. Surface can be used as a seed. So, once the definition is written, suppose I have written a definition where the surface is divided into smaller triangles. Now, I give any surface. It will convert that into different set of triangles. So here the surface is a seed. So now using surface as a seed, if I am getting that form, I change this surface to, let's say, complete recurrence, and then it will generate the same form. It will convert any form into a hexagonal grid with those pointed facade elements. Here, geometry is the same. So, suppose this one solid block is taken and then random points, number of points. So, I can change the number of points. So, one solid is converted into Bernoulli, 3-dimensional Bernoulli solids, and then I get that output. Imagine I change this solid into something else, I'll get a different output. Now, this is a very classic example where there are two seeds. So these two curves are one seed and then this one X-shaped form is one seed. Combination of that is generating the geometry. I take these two seeds, I get a different geometry altogether. Now going a little further ahead, I can use variable factors. So to understand this, it will take a little time. To actually do few experiments on this software. But once you achieve certain proficiency on this particular topic, what you can do? You can keep changing variables to create different patterns. So these are the iterations. And what these iterations can do? See, same definition is converting, is giving you these kind of iterations, these many options. And what I can do with them, I can give an attractor. So if I have a ball and I put one curve like this as an attractor and I use one definition, I can get this kind of varying form. So here, point attractor is there. That one point is there. The nearest to that point is a bigger opening. Longer to that point, I've got a smaller opening. And you get a very interesting form of opening. Something similar is happening here. Here the curve is the attractor. So you will be actually seeing some curves. So there is some circular curve. The image can be used as a seed. So there are two options for image and seed. You change the image and you will get a different design altogether. So this is just the kind of experiments you can do with parametric. So these are few of my projects where I did experiments successfully. So this is one lobby I am doing in Banal with the design. You can see this central portion, this is air precedence. So we have those different cylinders. Cylinders of same size with different projection is taking that. And you can see the free-flowing column. The column was there in the lobby, and those hidden lights into the ceiling. So the form is going in the top, and the entire thing with that reflective flooring that creates a corner. So it gives altogether a different look and feel to the basic space. Just one more lobby. Again, lobby, one of the lobby activities. So this was very basic. So when I started my experience in parametric. I tried first this ACE course in 2015. It was failed. The basic reason why I failed because I designed on computer and tried to execute it manually. So what you design on computers, you need CNC machine to do it. Otherwise you will fail for sure. And then I was so scared that in 2016 I said I'll do very safe experiment. I will not do it parametric at all. And again in 2017 I tried this. So I really like you to understand this was bold experience. It was so bold, it was so daring. I was traveling in Australia with the number of structural engineers and I said, now I'm going to make this structure in 2 days in exhibition. They said this will not stand. This will fall. The basic reason. If you see, the plywood is used, the plywood is used horizontally. When you use plywood horizontally and you put a point below, it will bend. When it bends, it will fail. It will break. So they said it will fail. But see the photo, it's 15 meters. So 6 meters by 15 meters, structurally safe. And I did it in actually 36 hours on site. So the first is finding the form. So you can see it's a very complex form. So on all the 3 axes, X, Y, Z. It's a very three-dimensional curve, which I actually took as a challenge. And the options I found on the net because I wanted to do it in plywood. These were the options. So I actually saw all of them very easy to make. And I thought I'll take the challenge which is the most difficult. So I tried to find the system and the form myself. So these are few options. So first I started working on the structural system. And you see, when I said I used plywood horizontally and flat plywood, and there was 1.8 ton of load wanted coming onto the horizontal plywood. So my assumption that when a plywood has got a triangular support at the bottom, when it is pressed, the tendency of the triangular support is to go away. So it will pull my horizontal plank and it will reduce the deflection. And when we actually work on it, it works that way. So the point was coming like this. Actually, deflection happens, supposed to happen like this, but because there is this action, it will pull that horizontal member. So the reflection was reduced. Now the bigger challenge, then I have almost like 2,000 pieces, all of different sizes, different shapes, interlocking each other. The bigger challenge was the situation like this. Then because of the angle, you will see this corner. If it is not calculated and 2,000 pieces, you cannot do it manually. So I think trigonometry. So trigonometry, taking the angle of 2 planks and then cutting that extra unit which is there. Or a situation where actually I cannot insert the planks. Once I insert the plank, with one slot and if the other slot is not matching, see here, if I insert the plank like this, these slots are not matching. So this kind of situation. So I have to do different iterations to avoid this kind of situations. And this is how the interlocking system works, a complex interlocking system. And this was the form which was written. That was the definition of algorithm. And you can see each slot was numbered, each plank was numbered with peak of each spot is different. You can see some spots are thin because they are crossing each other perpendicular. When the angle is there, then the spot should be bigger. So everything was calculated with the help of trigonometry. And that was executed. This is the final picture. So, once this experiment is successful, you become bolder, and then you think, I can do anything. So, next time I said, again 6 meters span, 15 meter long structure. I said, this time I use paper as a structural material. So, how paper takes that? So, we did our experiments. We made this pavilion. And for that, we did this study. So you can see every element is numbered. So algorithm is numbered there. And then because of the folding, the paper was the same. So 108 grams of one member was taking a load of 40 kg. Okay. Because of the folding. And then I made these star-shaped elements. And I took this. And you can see, I used the attractor. So the triangles are bigger in the front, they become smaller. The flowers are smaller, the stars are smaller in the front, they become bigger at the end. So every element is different. Again a shape which is three-dimensional. So you can achieve anything. And believe me, in the exhibition you get only 36 hours to do this. Maximum 48 hours. And you have to do it in 48 hours. So if you achieve this kind of perfection in 48 hours, you can do anything. This is the picture. So then we fail sometimes. So I said, okay, I can do almost anything now. So I tried this. And we actually completed the pavilion. This was the exact point of facade. And then we will go. In the morning, the person called me, Vivek, structure area. I said, what happened? What happened? So we understood that this is paper. Again, I use paper as a structural material. This guy in the night used paint, but water-based paint. So when you apply that water-based paint, the paper becomes soft. You know better, right? You are the expert. So, okay, these are few examples. Of course, one of the part is architect format. The lobby, we claim this is the biggest chandelier in the world, designed by Confluence. So the interior is done by Confluence. Interior is not my core competence, I told initially. So recently we completed this one building. The client didn't allow us to take the photograph, but we have visited this building. They said, hey, the client told me that you have designed the interior. I said, oh, yes, that is the first interior. In my career of 30 years, this is my first, actually my own interior design. I started out of work. And I supervised also. Thank you. So when I got this project, the client said, you have to do it. I said, I have not done any interior. He said, but only you have to do it. And I said, I will do it my way. So he said, what do you want to do? So I said, parametric. He said, what is parametric? So I started teaching him parametric. Now, giving that kind of taste first is very difficult. But my client was really open-hearted. Not that open-hearted. He's not allowing me to take the photograph. But anyway. So this is what we achieved. And you will see a lot of parametric elements here. So because this is the office of contractor, Kumar Infra. So they are dealing with a lot of concrete. Of course, everywhere the construction, their photographs are there. But then I take concrete as a basic material and tandem rubber wall, brickwork. I took those tools and I used them parametrically. And you will find them almost everywhere, like that partition wall there. And because I was doing an office for the first time, I said, should be something different. So I made a parametric unit, this workstation unit. So you will see, all these are different. So the name here and the name there is different. Because I actually made 5 different workstations in such a way that you can combine them together. And with those 5, I got 25 iterations. So now we have got 400, 500 people sitting. Okay. But you see almost every unit different because of these iterations. See, the name, you will see the arrangement. So every piece is unique. It's not unique. There are only 5 elements. I use the modularly. And you can see that sine curve on top. We call it sine curve in parametric language. So I use those rafters on the top to give that ceiling open, and I choose that actually combination, all the members are straight. And as I said, I use this random robot pattern and we use the CNC machine, a 5-axis CNC machine to get that partition wall. And actually giving a lot of alternatives, and he was not at all happy. And then I could literally sit with him for almost 3 hours to show him how this inception table is different than whatever is there in the market. So actually I twisted that form, scaled that one square, it's a square which is rotated and scaled down. And achieved that again for a kind of thing. This is one very interesting element on the boss's floor, the topmost floor. He said that whatever you want to do, it should be unique. So we imported Italian furniture, high-end Italian furniture from Thane, and I wanted the enclosure. So enclosure for VIP making, a big conference there, and there were 2 bosses rooms there. So I wanted the enclosure. So I used something like brick, but much bigger in size, and used it parametrically to get again a 3-dimensional curve. So you can see this is a basket. It's curved on all the 3 axes. And then we wanted soundproof as well. So everything was actually made in factory. The CNC machine were given each and every plywood dimension with even the locking system. So the top box and the bottom box, they get locked with each other. And this was the VIP rating. This is one picture which I have taken from my mobile, but this is the arrangement. And there is a slot which was kept in the factory where the glass was inserted. The DG was inserted, and it was kind of a Lego to exit to one side. And then you can see there are these different seals which are created inside those boxes. So initially the idea was to keep some good books and then some awards and office kind of thing. Then I thought this is the best use of it. So there is these different construction activities there in few of the boxes. One very interesting element is that food court. So I have this food court area here with 2 columns in between. So initially this was single column, then this column was added and this part was also converted into food court. But these 2 columns, so I use those lightweight materials, and with parametric I created this terminal form as a ceiling. So it's a bunch which is at the bottom in the belly, and those 2 leg kind of things, they are actually holding the column, and it's an open, half open ceiling. With that box form in the conference inside, the view with the actual picture looks much better, very impressive. Probably someday I am getting from outside. And again, And particularly this floor, this one workstation was to be designed. I said I am not doing anything which is delivered, I get done my own. So you can see this unit, one unit, is reversed and kept on the opposite side. So backside of that unit is a storage for the other unit. And we actually use a single unit working a zigzag kind of pattern, something like this. In the reception, I have these two big walls. So I thought of making something like this, which will change the character. So when you ask by it changes the character because of the protuberance. So the other wall was on this side. You can see on the top, it changes the character. Because the angle on one side is different, the other side is different. And the last, the glass wall. So I use the parametric to the same Bernoulli pattern, and you can find J model in that. And then in the lockdown, I thought something new to be done. Parametric was the overview subject, so I thought of doing Unreal Engine. And if you know what is Unreal Engine, it's a gaming engine. We play a lot of games, youngsters, so they are made in these particular software. And my son in first year architecture in LA, he his first presentation in Unreal Engine, the second presentation in Unity. So they are teaching it in the first year and second year, and we have to explore it ourselves. Because of my programming base, I can do this. So it's a visual programming. The language is very new to me. So I started doing that. And I created a space like this. And now I'm working on one project where you come on the airport and then you take a car, you go to the helipad, you take a helicopter, you land onto your site, and then you take a gold card and you go around in the site wherever you want to get out. It's like gaming engine. You must be using this a lot. And this is the end result. You can always change the color. You must have seen this. So I'm exploring this a lot. So next major thing is AI. So see, this is one topic very seriously we need to understand. When AI started 10 years back, everybody said the first job which we go is blue collar job. Okay. The second is white collar job, and finally the artists. They came all around. It has become artist job first. Okay. And now it has gone to such a level. I'm using all of these AI softwares, and every month there are 200 new softwares coming. Every month, 200. And what it can do? Unbelievable. So any technology starts from text. So you remember Telegram. So Telegram started with that typical power, fire, and then they are using 5G. So live video conferencing or real-time live conferencing. So the communication has come that way. Today AI is at the first stage, text. So what we do with AI, any AI implemented electric, artificial, Tane or any other software, we create prompts and it generates drawing, picture, whatever you want. Like yesterday, I have a very small photograph of my father. I'll show you it's my actually on the computer. So very small photograph, resolution was not that good. I put it in AI converted it into a fantastic painting. Okay. And then I wanted some text written on it. I did that. I said my father was a farmer, I want a farmhouse. I did that. Okay. And I said the photograph is small, I want to widen it. Okay, other size is one. Extend it. So AI does that. So mid-journey, before Thane, who is using mid-journey here? You are using mid-journey? Who has heard about mid-journey? None. Good. So this is generated have prompts. Believe me, you can get a lot of inspirational information, or you can do a lot of experiments with learning in Thane, and you can do wonders on that. Okay? So, direct output is like this, and in fraction of seconds, like this is 10 seconds job. And it gives you iterations, it gives you options. And you have to select from the options, and you have to further tell the software to evolve. Now, what makes you want? I want this color to be changed, I want that to be changed, I want 2 people inside, whatever you want. You can keep on doing it. Something which is absolutely out of the world, not possible, not thinkable, not profitable. It's a fraction of seconds. Yeah? You can keep on doing the options, you are not tired. Okay, keep on getting there. It is a library. You say, I want this, I want that. You are not taking care of the safety features, if you like that. If the light is there, if you like that. You keep on doing the prompts. And this is the beginning of it. As I said, Telegram के level पर है, 5G के level पर जाना है. So within next 3 years, only 3 years, AI is going to take over. Only people will be served those who are using AI on their work. And that's it. Thank you.
लेना है फोटो लेना है फोटो लेना
Does this parametric takes care of acoustic sensor while designing? Yeah, takes care of acoustic sensor. So you don't have to go for a separate consultant, or a consultant needs to be there.
You know,
Sorry?
how do we make testing? That internal testing I can do on my own.
Okay.
Only thing is, people will not believe it.
Right.
Okay.
Well, you make a
So
custom.
they want to spend the 50-60 lakh rupees additional and get it tested.
So same thing applies for acoustic sensor.
All the simulations are available. All the simulations.
Great. Thanks a lot. Thanks for your presentation.
Testing. Ladies and gentlemen, he deserves a thunderous, a huge round of applause. Architect Vivek Bhole, I must say, he has explained the concepts and the capabilities of AI, the future of software technology. Okay, we have some more questions.
Yeah, hi sir. Thank you for a fantastic presentation. I was honestly awe-inspired. But I have a very big question for you. As a user of mid-journey of AI and some of the design software that you have mentioned, it's a beautiful world that where we live in, where we can create these things digitally. You have done a brilliant job of getting into life. But as an OEM, as a manufacturer in India, how capable is India today, and how capable do you believe it can be in the future to bring these designs to life?
Okay, so see, even I thought 6 years back when I started executing this project, it's not possible. But when I saw the capability of CAC machines, okay, and they are evolving, the 3D printing is evolving. So 3D printing is evolving, and possibly within the next few years, you will get almost everything 3D printed. When I say everything, is almost 99% everything.
So 3D printing is not size a problem. Your scale cannot increase a certain level with 3D printing, right?
No. There is one more, and you see entire gantry, industrial gantry can be used to 3D print a huge building. Okay.
Anchor madam, with your permission, can I say a share on शायरी on sir? काम करो ऐसा, whatever I'm speaking शायरी, it describes life. काम करो ऐसा की पहचान बन जाए, कदम करो ऐसे ये एक निशान बन जाए। जिंदगी तो यूं ही हर कोई काट लेता है, पर जिंदगी जियो इस कदर के मिसाल बन जाए। But I would say, one who has entered, you are a gem of a man and man of substance. And I request you for this standing ovation from the audience.
Super, I must say that says it all. I must say, he's extremely one passionate person about his work, a creator, an innovator. I think इनकी डिक्शनरी में impossible शब्द है ही नहीं। इतना तो इनकी जो प्रेजेंटेशन में I am inspired, trust me. Impossible जैसे कुछ करना है कर सकते हैं। Exactly what he has displayed into his entire journey. Ladies and gentlemen, once again, come on, Architect Vivek Bhole, thank you so much. So we have a memento for you. May I request Architect Sujit Gadkari to please come on stage to present the same.
He took us into a different world, I would say.
He was just telling, he's just gone off. Okay, easy on himself. तब तक इनके लिए और एक बार जोरदार तालियां हो जाए। Come on, you gotta keep clapping. I think how much we clap for him is less. Here he is. Here we go, ladies and gentlemen. Huge round of applause. जोरदार तालियां हो जाए। क्या हुआ उन लोगों को एनर्जी लेवल हुआ? Once again, thank you so much for being here with us and sharing your expertise with all of us. Thank you so much.